So hello everyone. It's really nice to be here in the good campus for this session about the emulation of SONiC. So my name is Shenglin from the Android electronic team, and this is my partner Feng from Cisco. Yeah, and this is our patents. Yes, to start with, I'd like to introduce some background about why Alibaba is this one-to-one simulation system and why we chose the NGDP. And also next, I will dig into some details about the system, that's including how we create this one-to-one topology, and as well as our new tool named NRC. So yes, we use this tool for the traffic and the routes injection. And at the same time, there will be a demo video for our system. And yes, you will see there the overview of our system and how we use the NRC. And then last, my partner Feng will introduce the NGDP with more details. There we go. Yeah, and based on the same topology and the same configurations, so Alibaba now is able to build a digital twin for online routers and switches. And from our experience, we benefit a lot from this system. For example, the architectural verification and DevOps validation, and also for troubleshooting of online issues. All of this stuff can be done in this system. And please be noted that all the virtual device in our system is NGDP based with SONiC. Yeah, there are main two reasons that we choose NGDP. First, NGDP is chip level simulation. Yes, this enables us to test for vendor side or even vendor SDK or even the people tables of hardware. Yeah, and second, the NGDP has high data forwarding throughput, so this enables us to the high fidelity simulation of our routers. Okay, let's show some key technologies we used to build our one-to-one topology. Yes, number one, we use the VM in Docker. Yeah, so this enables us to orchestrate. This enables the easy orchestration of large topology among different physical servers. And number two, all the VMs start up the same config files of our online routers. And number three, all the VM to VM link is based on the TCP. So this enables the cross-server VM connections. So here is an example. We are to set up a VM with multiple ports. So please refer to the screenshot on the bottom. This is the parameter we use to start the QME process for the VM. As you can see here, different ports of the VM will use different TCP ports. Okay, this diagram shows the inner details of how our VM to VM link is connected. Generally speaking, on each host, we will have our mesh service that is used for switch packets. And on the mesh service, each VM to VM link will have two standalone sockets that is used for switching packet on the specific link. Okay, so to inject traffic and route into our virtual device, we implemented our new tool that we named it the NRC. Yes, it is totally an open source based traffic generator. So for example, it uses the FR to establish BGPs and inject routes with the virtual device. And it uses the T-Rex to send the packets to the virtual device. And usually the NRC externally connects to the one-to-one topology, and it acts as a real user of the packet topology. So here is an example. So in Alibaba's SRv6 DCI network, there are many 4 types of devices. That is EC. So this is our national P routers, and also EAR. This is our regional P routers, and next ESR is our P routers, and MC, the CE routers. So in this example, our target topology is all the ESR and ERs of a region of Alibaba. So, and also another 2 NRCs are connected to the target topology and the role of MC. And our third NRC is connected to the target topology and the role of EC. So based on this simple topology, the intra-regional traffic can be verified based on the 2 MC NRCs here. And the inter-regional traffic can be verified based on the NRC EC and the NRC MC, and vice versa. So now we have a demo video for our system, and you can see how our system looks like and how the NRC get used in our system. The sound. Sorry. The sound. Okay. So the one with the video, we have no voice here. Sorry.
This is a demo of Alibaba digital twin system for networking routers and switches. In this demo, our target topology is the 304 online DCI routers within a region of Alibaba. And this diagram shows how these routers are interconnected with each other. Except routers, and there are 3 NRCs connected to the target topology used for traffic and routes injection. Here is how Alibaba's one-to-one simulation system looks like. For the demo topology, there are 304 devices plus 3 NRCs. So totally 307 nodes are showed in this virtual top. And the first 3 nodes are NRC nodes, and all the other nodes are device nodes. You can log in any device in this portal. I will take our device for example. I can log in to this device. Here we are in the virtual switch. To compare this virtual device, I also have a portal that can connect to the real online device. And this one, and we can see that they are pretty much same. First, we can check the configs these 2 devices running on. And for the real device, we can see that the configs pretty much same. And then last, we can check the roots on these 2 devices. This is the virtual device. This one is the real device. And you can see that for the EGP routes and the IGP routes, they are same on these 2 devices. Next, let me do the traffic verification based on this virtual top. Here I use the NRC EC and the NRC MC2 for inter-regional traffic verification. So first we find the NRC MC2 in our top. Yeah, this one. We can log into this node. This node acts as a traffic sender. All the traffic verification is based on the TREX. Also, to simplify the usage of TREX, we implemented a suite of RESTful APIs to control the TREX. For example, this curl command will trigger TREX to start the traffic on all its 16 ports. The test address of the traffic is A.132.19.1, and the packet PPS is 5 key on each port. So the total PPS will be 8 key. We can use the TCP dump to check the real traffic that this NRC sent out. And also we can use this command to check the TREX packet counters on each port. We can see that on each port, it has a TX PPS of 5 key. This works as we expected. And receiver side, let's find out the NRC EC in our top. And it is this one. We can log into it. Also on this NRC EC, we can also check the traffic that arrives with TCP dump. For example, we can find out that all the traffic is with SRv6 encapsulation. And also we can use this curl command to check the TREX counters on the NRC EC. It is very easy to find that the traffic is balanced among the first 16 ports of NRC EC. Each port have a RX PPS of 5 key. All the 80 key traffic is received on EC. There's no packet loss. And last, let's check the traffic on the SONiC virtual device. And this SRv6 route shows that for the customer traffic packaging to this address, the P device will encapsulate with the corresponding SRv6 VPN header. Here, I want to highlight a benefit of with SONiC. You can capture any data plane traffic with TCP dump. For example, this is the ingress customer traffic, and this is the encamped SRv6 VPN traffic this device sends out.
Okay, that's it. So let's go back to the slides. Sorry. Sorry for the accident. So this is my last slide. Yes, I list the key features of our system here. In word, we have one-to-one topology and one-to-one configurations and one-to-one routes compared with the online devices. And all the traffic verification is based on the TRX. Okay, I will hand over time to my partner.
Hi everyone, I'm Feng from Cisco. So very great to see a demo that show the NGDP working in action and compared to the hardware. So it's a great demo. So I'm going to talk about NGDP today. So NGDP is a fast MPU simulator for the 8000 Cisco 8000 MPU. So basically a P4 simulator. And so there are some reasons that it's very fast. So like, for example, the P4 is a very high level abstraction of the network processing, packet processing. And so it's much higher than the C and register level. So it's easier for simulation to get some speed. Also, from the ground up, we designed the system to be multi-threaded and introduce some lock-free design and use some advanced queuing stuff techniques and batch processing memory pool management. And also, we have some very advanced data structure and algorithm for the high performance table lookups. Also, we improve bit operations performance by eliminating the dynamic memory allocation. So also to ensure that the accuracy of the model, so we have a comprehensive test environment, automated CI/CD infrastructure, and a very range of the test suites from unit test, SDK level, system level, and the network level. So all this to make sure that we have a very good accuracy compared to the hardware. So here's some PPS numbers. So originally at the beginning of the project, we have a base AK P4 SIM. That is for the P4 development. So it has all these debugging features and very good tool, a very good simulator. But it's very slow, about 150 packet per second. So so this is not enough for our system level simulation. So that's why we start our the new project that's we call NGDP. And our initial target is 10K PBS for comprehensive system level testing and development. And so our first iteration is we got 50K, and then the next one gets 200K, and now we are in the third stage. We have almost 1 million PPS in some cases, some cases. But I mean, the base simulator is still very good. and especially for the P4 development. So yeah. The next one. So based on the NGDP, the data path simulation. So we have this SONiC VS with NGDP. So basically, with the upgraded SONiC virtual switch, including all the Cisco SI and SDK and our NGDP model in it. Also, it provides same software stack as hardware, and it's free for development. So it's cost nothing to for the developer to use on the or develop software for real hardware. So yeah, that's good. Also, so the package itself includes all the binary and the script and all the patches to the SONiC tree. So we already support several versions of SONiC and all the so multi-generation NPUs, and it's really fast to boot, 30 seconds and 36 seconds to the interface up. The last one, how do you get it? So we have you can go to the search.cisco.com and search Cisco VS and to get the link and just start downloading and start using it. So
okay.
That's what we
I take this. Yeah. So from Alibaba perspective of view, so it is very useful for the NGDP. Yes, we call for actions from the community that we work together to upstream the answer codes and also build more test cases for the NGDP-based resolve. That's all. That's all I can.
Oh, yeah, maybe take one question.
Yeah, okay.
So yeah, thanks for the talk. I have like really short question. You said this NGDP is the P4 simulation emulation. Doesn't mean that you've modeled the SI pipeline in P4 and running it as the P4 program? And if yes, are you going to upstream this as the part of the maybe pins or something like that?
Sorry, it's a side what?
So okay, I will.
Sorry.
Yeah, sorry for that. Maybe I will simplify or rephrase. The NGDP is the P4 simulation or execution environment, my understanding.
Yes, that's correct.
So in order to run SONiC VS on top, you had to model the SI pipeline or how SI expects packet to flow from the high level perspective to the P4. If this is true, are you going to upstream this model, this P4 program, how SI should work in P4? And if any correlation between the pins project which is trying to do the same?
Maybe I can take this question.
Okay.
Yes, I think this NGDP is the low layer simulation for the chip. So I think
It's chip level.
yeah, it's chip level. So it has nothing to do with the side layer. Yes.
Okay, thank you.
Quick question about the mesh service. Is that open source, or are you going to make it open source?
Yes, it is on our to-do list. You know?
Okay,
Yeah.
thank you.
Since this is a very big system, so couples of our teams from Alibaba cooperate on this project. So I will say yes, it's our to-do list. Finally, it will open.